keywords final and static. There are 4 combinations in which we can apply these keywords. A field can be not final and not static, and then it is an instance field. So it belongs to every instance of a class has its own field as declared. We can make these instance fields final, and then it becomes immutable. That means unchangeable, and it's fixed. Once its value is assigned, it cannot change. And we use this a lot. But then we can also make a field static but not final, and then it is a class field, and it is shared by all the instances of a class. So there's only one field, not one field for each instance. It's kind of like a global field. And sometimes we make these static fields final, and then it becomes a constant. So some constant provided by the class to its users or for internal use. So we're going to look at all 4 of these cases. So let's start with an instance field. Here is class turtle. It has these fields x, y, and a to indicate its position and the angle it's facing. They're not final and they're not static. So every instance of turtle will have its own copy of x, y, and a. There are methods we can apply to the turtle. So let's see how this is used. Here is my turtle prog. It declares 2 instances of t1, and it calls the constructor for each of them with a 0, 0, 0 for x, y, and a. So what Java does is it creates a t1, which is a reference to an instance of turtle with x0, y0, a0, and this is just a little picture to show what this is representing. It's like a visual representation of these fields. And there's also a t2, which is separate from t1, a different instance, and it has a x0, y0, a0, so the visual representation is the same. Now I can apply the go forward method to t1, and what will happen is that the t1's x will be incremented with 10, so t1 has moved. It's now at that position and the turtle has drawn a line, but t2, a separate instance, has its own copies and they're still 0, all 0. And in the next line, I'm going to turn t2 left. So we call the turn left method on t2, and now t2 has changed its direction and its angle is changed, but its position is still 0, 0, and it is separate from t1. So these fields are instance fields. Every instance has its own copy, which it updates separately. Right. So that's not final and not static either. But let's look at what happens if we make a field final, one of these instance fields final. So here is a different class complex. It has 2 fields, RE and IM, for the real and imaginary parts of a complex number. And these fields are final. So they're not static. Each instance will have its own copy, but once they have a value, they cannot change. So here is a little program. Complex computation creates a C1 instance and a C2 instance, and it passes these 4 values as the real and imaginary parts. So Java creates C1 with real part 1 and imaginary part 2.5, and it also creates C2 with real part 3.0 and imaginary part 4.5. I cannot ever change these instances. I can change C1 and C2 by assigning them to point to other instances, but this particular instance here will never change its values. And therefore, if I want to add these 2 numbers, I cannot add C2 to C1 and update this 1.0 and 2.5. What I have to do is, the way this is written is that the plus method takes a complex number to add to this instance, but then it creates a new complex number that will be the sum. So I can write C3 is equal to C1 plus C2, and that will create a new complex number, which is 1 plus 3 is 4, and 2.5, 4.5 is 7. So these are immutable fields, and we often use them for classes that represent a value like a number or anything that won't ever change its fields. Right, so we've looked at immutable instance fields and instance fields. Immutable is good because it protects us from accidentally changing a field. Let's look at static class fields that are shared by all the instances. And we'll work with complex again. Here is class complex. It still has the final RE and IM field, but now it also has a field count, which will count the number of complex numbers I've created. And it's static, so it's shared by all the instances of class complex. When I create a complex number, this is the constructor, I take a real part and an imaginary part, and I assign it to these final fields. So now they're assigned and they won't change again. But I also increment count. So this is a new complex number I create. So I increment the count of complex numbers that I've created. It's not final, it can change. And it is static, so it belongs, all the class instances share this value. Let's see what happens. Here is class complex computation now. Before I even start creating these complex numbers, Java creates an instance of the, not an instance, but a representation of the whole class with that static field count, which is 0. It's initialized to 0 at the start. And when I create C1, it creates the instance with its instance fields, RE and IM, with values as before. But part of this constructor is to increment count. So therefore count now becomes 1. And if I create a second complex number, C2, with these fields, Java creates a new instance, and C2 is a reference to that instance. But part of this constructor is to increment count, so the global count now becomes 2. So this is like a shared variable, a variable that is shared between all of the instances of class complex. Okay, so that's not too hard. Lastly, let's look at a constant field. One that is final, it won't ever change because it's a constant value, and it's also static. It's shared by all the instances of the class. So here I have class complex again. It still has the instance fields RE and IM that are final, but it also has this field. The name is 1. Ooh, I don't want to move that. The name is 1. The type is complex, so it's actually a reference to an instance of the complex class. It's final, so it won't ever get another value. This will be the value it keeps. And it's static. Everybody can see it. It's also public, so we can see it from outside. So here is a little program, complex computation. Before it even starts, Java creates this static field that will be shared by everyone. So complex has the class has a static field called 1, and it's a reference to an instance of this class, of itself. So an instance is created with real part 1 and imaginary part 0, 1 and 0, and 1 is a reference to that instance. There's nothing wrong with this. This works perfectly. So when I create a complex number C1, well, just before I show you the picture, I'm passing the real value 1.0, but the imaginary value is math.py, which is its own static final field in class math. So somewhere there is a class math, and it has a public, static, and final field called pi, which is a double, and it has the value of pi. So it's this value that I'm accessing like this, and I'm passing it to the constructor for complex. So it will create a C1, which is an instance of class complex. The real value is 1, imaginary value is 3.141. Before I go on, I should mention that we usually use a convention that static and final fields, so constants, are written, the names are written all in capital letters. The other convention we use is that classes start with a capital letter and fields and methods start with a small letter. So this is just a convention. You could write this big R, big E, big I, big M, but nobody does that because it confuses people. I mean, if something starts with a capital letter, people assume that it's either a class or maybe even a constant. So let's stick to this convention. In fact, Eclipse will complain a little bit if you use the wrong capitalization. So here is C1. We've created the instance with this real imaginary part, and now we're going to add 1, the constant, this one, to C1. And the plus operation creates a new class which we store in C2, and it is added the 1 and that 1 to get a 2, and pi and 0 to that stays pi. So here is an instance of the sum of C1 and 1. Right, so now we've looked at all 4 of the combinations, but I just want to show you one more thing, and that is what happens if we make a mistake. What happens if, for example, we try to create a constant, and I don't want to call it 1, so I call it oh no. It's final, so it'll keep this value, but I didn't make it static, so it's not shared by the whole class. Every instance of complex will have its own copy of oh no. What will happen? Before, we did have the static, and then it was shared by everyone. But now, every time we create an instance of complex, like C1, with real part 1 and imaginary part pi, C1 will have the R and RE and the IM fields. Remember, they're final, they won't change. But it also has this oh no field, which is also final. It will only ever, it won't ever change. And every time it's created, it creates a new instance of complex with real part 1 and imaginary part 0. And oh no, this instance, for this instance, points to this instance. And when I create C2, it will do this. It will create a C2 with a real part and imaginary part and its own copy of oh no. So you have to be careful that you don't miss out the static if you want to create a constant. In fact, this code won't work perfectly because complex.ohno does not exist. I can only use this notation for static fields that belong to the whole class. I could have written here C1 or C1.ohno, in which case we've added this ohno field to C1's field, and we get this result. Doesn't matter because this is not the right way to do this. So I hope that's a little clearer, and you should be comfortable using static and final because they're both very important in different contexts.